Okay, we are solving rational equations. Rational means they're fractions and there's letters in the denominator, usually. So, step 1, find your domain. You're literally looking for what the denominator cannot be. A big reminder here is that it's okay to have a 0 on top. It's not okay to have a 0 in the bottom. So, okay, no, it's not allowed to be 0 in the bottom, which is what we're going to think about whenever we're finding what it can't be. You have to find your least common denominator and then cancel the denominators to solve. Yes? Okay, solve for x, check answers, extraneous solutions. Now these solutions are a little different actually. Monday you would solve and you would get a number and then it didn't work when you plugged it in, right? Same concept today, except it doesn't work because it'll make your denominator equal 0. So that will make more sense here in a second. And it also says, reminder, you can only cross multiply if it's a single fraction on each side of the equal sign. So like here, you see how you have 2 fractions equals 1 fraction? You cannot cross multiply here. Okay. However, if you look at your practice on like number 2, you can cross multiply. Does that make sense? Because it's a single fraction equals a single fraction. Okay, so let's look at number 1. So first things first, we want to find our least common denominator. Now, we look at our denominators, and I have 18 as the biggest one. Can 9 turn into 18?
Yeah.
Can 2 turn into 18? Yeah. Then 18 is my LCD. Now, this is going to make more sense when I get to number 2, but your domain here is all real numbers because there's nothing I can plug in for t that's going to make your denominator equal 0 because there are no t's in the denominator. Does that make sense? Okay, so that, like I said, it'll make more sense when we get to number 2, but it can be all real numbers because there's no letters in the denominator, no variables in denominator. That's why it's all real numbers. Okay, and then now we just solve. Well, to solve, I have to create the common denominator on all 3 terms, and I have to cancel it. So how do I turn a 9 into an 18? Times 2. How do I turn a 2 into an 18? Times 9. Now I also want you to realize this is subtraction in the middle, so I'm going to bring that subtraction sign up and cross this one out so that way I don't forget about it. Because if you're like me, you're just going to distribute a positive 2 when really you should be distributing a negative 2 if you forget about that negative. So now 9 times 2 is 18. 2 times 9 is 18. Do all my denominators match?
Yes.
Then we can cancel them. Because this is mathematically why. If I multiply both sides by 18, doesn't that just cancel the division of 18? Yeah, so that's mathematically why we're allowed to do that. So knowing that, we're going to solve the top. What's 9 times t?
19.
9 times negative 4?
Negative 36.
Negative 2 times t?
Negative 2t.
And negative 2 times negative 3?
That would be
That's so hard.
positive 6.
Positive 6 equals 5. Because we didn't have to change that.
Why is it negative?
Because remember it was minus, so we brought that minus sign up.
Oh.
And I crossed it out because I didn't want y'all to think there were still 2 of them. Now, can I solve that?
Yeah.
Yeah, nothing's squared, so I don't have to get it equal to 0. I just have to solve for x. So what's 9t minus 2t?
17.
And then what's negative 36 plus 6?
Negative 30.
Equals 5. Now what? Add 30 to both sides. And I get 7t equals 35. Last step. Divide both sides by 7. And what do I get? Now, there was no limitations due to my domain, so 5 is my answer. However, you can always check your work. So we would do alpha y equals enter 5 minus 4 over 2 minus 5 minus 3 over 9, and it should equal 5 over 18. Did it work? Yeah. Okay, so we're good. 5 is my answer. Okay, so look at number 2. Number 2 is a little different because we have binomials in our denominator, and we can't separate them because they're together and we don't have anything on top to separate. So I have this whole thing times this whole thing. When you have that in your denominator, your LCD is just the 2 of them multiplied together. You don't actually have to double distribute them. You can leave them like this. It makes it easier. Well, knowing that, your domain, because remember we're not allowed to have 0 in the bottom, is what would make either of those factors equal 0. A lot of times you can just look at it. What cancels a positive 2? What cancels a negative 5? So those are your two numbers that x cannot be, because if I plug in negative 2, doesn't this factor equal 0?
Yeah.
So this would be 0 here, and is that allowed? No, that's y. However, if you ever look at it and you're like, I don't know what cancels that because it has a number in front, you just set them equal to 0 and solve. So minus 2, x equals negative 2, and that's why negative 2 can't be a solution. X minus 5 equals 0, plus 5, x equals 5, so that's why 5 cannot be a solution. You just set your LCD equal to 0 and solve. To find your domain. Okay, any questions with that? So if I solve this and I get x equals 5, well, is it allowed to be 5? No. So I would tell you no solution, because my solution didn't, I'm not allowed to have it. Okay, these are the ones you're not allowed to have. So knowing that, let's solve this. Now, there's a couple ways you could solve this. However, it equals 0, and I have a negative. Can I move this over and it be positive? Yeah, so I could add 6 over x minus 5 to both sides. And I get 7 over x plus 2 equals 6 over x minus 5. Is it a single fraction equals a single fraction? Yeah. Okay. However, if you don't notice that, that's fine. If you'd rather just follow the other steps, this has x minus 5. What is it missing? So I would multiply top and bottom by x plus 2. This has x plus 2. What is it missing? Do they both have the same denominator now? Yeah. So I cross it out and solve the top. So what's 7 times x?
7x.
And 7 times negative 5? Equals what's 6 times x?
6x.
And 6 times 2?
12.
Now when we get to this point, I always like to move my smallest variable first when there's a variable on both sides. So which one am I moving? 6. So I'm going to do minus 6x minus 6x, and that gives me x minus 35 equals 12. Now what?
Plus 35.
Plus 35 on both sides. And I get x equals 47. Now, is that one of my limitations?
No.
So it's allowed. Any questions so far? Okay, so look at the back. Okay. So if we look here, I see I only have one fraction. However, I have 4 terms. This is a term, this is a term, this is a term, this is a term. Yes? What's my denominator in my one fraction? So the nice thing is when only one of them is a fraction, that's your least common denominator. And what can x not equal? 0. Now, if I have an x here, I can, if I put an x in the bottom, I have to give it to the top. So bottom, top, bottom, top. Are all my denominators now x? Yeah, and you'll notice that second term didn't change because it already had the x, right? So now that they all are x, we can cancel them. And we're left with 3x minus 6 equals x squared plus 8x. Okay, now what do I do? No, we don't ever want to make x squared negative. Because we have a squared, it's just like Monday, and we have to set it equal to 0 to solve it. We either have to factor or do quadratic formula. So I'm going to do minus 3x on both sides because we don't want a negative x squared. And I'm going to add 6 to both sides. And now I have 0 equals x squared plus 5x plus 6. Now that it's equal to 0, can I do either quadratic formula or factoring?
Yeah.
Yeah, if you prefer quadratic formula, you do you. I'm going to factor it. So I know that a is 1, so 1x, 1x. What's a times c?
6.
What's b?
5.
What multiplies to give you 6 and adds to give you 5? So x plus 2 and x plus 3 are my factors. And I'm separating them because to solve, I have to set them both equal to 0 and solve. So minus 2, x equals negative 2, minus 3, x equals negative 3. Well, neither of those are 0, so I'm good. Any questions with that one? Okay, so let's look at example 4. So here we have 3 fractions, but 2 of them already match. So I know for sure that's going to be part of my LCD. And what about the other one? Well, I can't get rid of it, so it's also part of my LCD. Now, just because you have x plus 2, x minus 2, x minus 2 does not mean you need x minus 2 twice. If it already matches a little bit, don't make your life harder. Yes?
Yeah.
Okay, so knowing that, I'm going to go ahead and get rid of this negative first. Now, because it looks just like part of the line, I always like to distribute it in first. So that becomes negative, and this goes away. Because you have to give the negative to that whole term. And now I can create a common denominator, and I don't have to distribute the negative later. So what does the x plus 2 need to be part of the, or to be the LCD? Yeah, so if I give x minus 2 to the bottom, I have to give it to the top. This one has x minus 2, so it needs the x plus 2. Has the x minus 2, so it needs the x plus 2. Do all of my denominators match? Yeah, so now we can cross them out. And I need to multiply. Now this one looks really gross until we simplify it, so don't freak out. X times x is x squared. X times negative 2 is negative 2x, so there's my first term multiplied. Here, my second term, I need to double distribute. So negative x times x is negative x squared. Negative x times 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times positive 2 is negative 4. Equals my last term's multiplication. So x times x is x squared. X times 2 is 2x. 3 times x is 3x. And 3 times 2 is 6. So like I said, looks super gross. But once we start combining like terms, it'll look just like number 1. Or number 3, sorry. Okay, so now looking at just the left side, what are my like terms? Yeah, what's x squared minus x squared though? Yeah, they cancel. Now what? Yeah, negative 2x minus 2x minus 2x is what? Negative 6x. Did the 4 have a like term?
No.
So I just bring down the minus 4. What are my like terms on the right side? Bring down my x squared plus 5x plus 6. Now does it look just like this step in this one? Yeah, so now we know what to do. Because there's a squared, I have to get it set equal to 0. So don't move your x squared because your x squared's positive. We're going to add 6x to both sides, and we're going to add 4 to both sides. And we get 0 equals x squared plus 11x plus 10. Now what? Factor it. Yeah. So what multiplies to give you 10 and adds to give you 11?
1 times 10.
1 times 10. So I have x plus 1, x plus 10, minus 1 equals 0, sorry. X equals negative 1. So I know, before I do that, what's my domain? What would make either of these equal 0?
X minus 2x plus 2.
Yeah, positive, negative 2 and positive 2. Not x minus 2x plus 2. The actual numbers. Are either of those that?
No.
So we're good. Okay, let's look at example 5. Now, 5 and 6, you'll notice have denominators that can simplify, or not simplify, but factor. Okay, what's your GCF here? Because before I even do that, do you notice that none of these look like they match? Like, you would have to make a huge denominator if you don't do this. So if I take out my GCF, do you see that now I just have x minus 2? Now do they have something that matches? Yes. So I know that x minus 2 is part of my denominator. Okay, but this has a 6. Can 3 turn into 6? By doing what? Times 2. And can you multiply this one by 6? So then 6 is your number. Now before I keep going, what is my domain? Positive 2. 6 doesn't matter because it doesn't have a letter, and we're only concerned when there's letters. So x minus 2, what cancels a negative 2 is a positive 2. So that's why x cannot be positive 2. So knowing that, we need to make all of our denominators be 6 times x minus 2. So here I'm going to multiply by 2 on top and bottom. Here I'm going to multiply by x minus 2 on top and bottom. And here I'm going to multiply by 6 on top and bottom. Are all my denominators now 6 times 3x minus 2? Yes, so knowing that, I can cancel them. And I get 2x plus 2 equals 5x squared minus 10x plus 6. Because I have a squared, what's my first step? To get it equal to 0. So I need to move my x squared's positive, so I leave that side alone. I need to move all the things on the other side. So minus 2x, minus 2x, minus 2, minus 2. And I get this. Now, we haven't factored something where a wasn't 1 in a while, so let's watch closely. A is 5, so we have 5x, 5x. What goes on top? 5 times 4, which is 20. What's b? Negative 12. Now, my numbers that multiply to give me 20 and add to give me negative 12 are negative 2 and negative 10. Does 5 over 2 simplify? No. Does 5 over 10? What does it simplify to?
X minus
1/2. So this comes over as x, and this comes over as a minus. So I get 5x minus 2 equals 0, and x minus 2 equals 0. So I get 2/5. And I get x equals 2. But what did I say x cannot equal? 2. So my only answer is 2/5, and my extraneous answer is 2. Yeah. Okay, we're not going to go all the way through number 6 just because it gets repetitive, okay? But I am going to talk to you about something. Here we do have to factor this because we have to see if anything matches in factored form. Okay, so knowing that, what I want you to realize is, do you think I'm ever going to give you a billion different factors for the denominator?
No.
So I know that a times c is negative 18, b is negative 3, a is x. Does negative 6 times 3 give me negative 18 and add to negative 6?
Yes.
Yes. Okay, it's just your factors over here. So knowing that, I have x minus 6, x plus 3. Always check it just to be safe. But now, what's my LCD going to be?
It's going to be positive.
Yeah, x minus 6, x plus 3. And then x cannot equal negative 3 and positive 6. And then you would go through and solve. Okay? So not too bad.
So with the last one, it would be like both of them, x minus
Well, this one has x plus 3, so it needs the x minus 6.
1. Okay.
This one has the x minus 6, so it needs the x plus 3. And then these match, so we can cancel. Now solve. You didn't have to multiply this one at all because it already had both. Yeah. Okay, a couple things on the practice. We didn't finish, so don't worry about this. Okay, look at number 1. Yeah, could you technically cross multiply? But here's my question. What do you notice about the denominators? They already match. Don't make your life harder. So what's your LCD? X plus 1. And what can x not be?
Negative 1.
Negative 1. So we cross off the denominator and we solve. Yes? Do not overthink it. Now, another thing. 2, yes, you can cross multiply. It's an easy one. However, I would not cross multiply on number 4. Because you have squareds and you have all this other stuff, it's actually easier to not cross multiply. Okay? However, this is a perfect square minus a perfect square. Do y'all remember how to factor those? What times what is x squared? And what times what is 1? 1 and 1, so this is x minus 1, x plus 1. Why did I write 2? I don't know. So on and so forth. Okay? That's a 1. I'm sorry. I don't know why I was writing 2. Mentally, I said 1 and then I wrote 2. I don't know. Okay, on number 3, I'm going to be nice. I'm going to tell you that that is those factors.
Thank you.
I'm also going to tell you to be super careful on number 5 because this 1 is there and it doesn't have a denominator, so do not forget about it. Okay? In just a second. Any questions with that? Yeah, okay. This is what you're working on. If you have questions, what should you do? Ask.